Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Imam bin Daud. Today, I would like to present project circuit diagram for the project microcontroller. We using the Arduino Uno and two button, one for on off and one for reset. For the insulin glucose sensor, we using variable resistor, and for the buzzer we using buzzer, and for the display we using LCD 16X2, and for the insulin pump we using DC motor for the output insulin pump. For the flowchart of operation, okay, we start with button on off and go down for the glucose level sensor, and we will display at LCD display. And for the decision, if glucose level is same equal to 150, and yes, buzzer will on for 30 seconds. If glucose level is not 150, the decision will go to another decision if 50 glucose sensor or 150 greater and same equal and greater 150, then yes, insulin pump will on. Okay, if not, if glucose level below 50, then insulin pump will off. Same with the buzzer will off after, if not 150, the buzzer will off for the 30 seconds, and insulin pump will off after glucose level sensor below 50, and if glucose level sensor is not under 50, then decision will go no up to the, if glucose level sensor equal to 115, and they will loop for the glucose level sensor detect what glucose level, and then the flowchart will go to the end. Okay, for the project coding, I'm using Arduino coding. For the first paragraph, include liquid crystal. Liquid crystal is for the LCD 16X2. We're using port 12, 11, 5, 4, 3, 2, and initial port 1 and 2 is for the variable sensor. Initial button 1 and button 0 and A5 for the on off button, and the buzzer will come for the output. And initial ENA equal to 8 and initial IN1 equal to 9 is for the DC motor. And void setup LCD print glucose level. We will pop off at LCD display glucose level, and pin mode for the input is button, of course, and for the output buzzer initial 1 and ENA. And then we come to the loop, void loop, port 1 analog read A0 is for the variable sensor, and button digital read button 1 for the push or not push the button. Analog read ENA 255 for the speed for the DC motor. Okay, first, if button height, button for the on off height, the potentiometer will detect, variable sensor will display the glucose level 150 and below. Okay, if port 1 equal to 150, turn buzzer 1000. 1000 mean the frequency for the buzzer, and delay 500 for 30 seconds, and Norton will stop the buzzer for 1 minute. And next, if port 1 greater than 50, digital write initial is high. If port 1 below than 50, the digital write initial is low. For the DC motor, initial one for the DC motor, if greater than 50, it will on, and below than 50 it will off. Okay, else for this is for the button, if off, everything for the hardware is low. Okay, for the figure 4 show the glucose level 50 and DC motor start to on. Okay, glucose level 50, this 50, the buzzer off, the DC motor start. For the button, it will start, and the available resistor is 50. Okay, next, the figure 5 show the glucose level 150 and buzzer start to on. Okay, glucose level 150 and button on off, variable resistor is 150, and DC motor will start still on, and the buzzer is on. Okay, for the simulation, I will start the button off. Okay, for the whole simulation, buzzer not on, DC motor not on. Okay, I will start the button. Okay, the buzzer will on, glucose level 150, DC motor is start on. I will variable resistor come down a little bit. Now it's 109. We go below to 50, 70, 60, 50. Okay, for the 50, below than 50, 49 is the DC motor will off. Okay, if I go back to the 150, the buzzer will on, DC motor will on. Okay, buzzer will on, DC motor on. Okay, okay, that's all for my presentation. Okay, I present the project circuit diagram and the flowchart, the coding, and the result for the simulation. Okay, that's all from me. Thank you.
Hi, Assalamualaikum. My name is Muhammad Rizwan. My matric number is CN190089. For my part, I will explain about the project cost and bill of material. For this project, we are using at least 10 components uh, to make the portable pump, glucose level pump. The first component are Arduino Uno. We are using only one Arduino Uno. Arduino Uno is the microcontroller or the brain for this project, which is cost for 80 ringgit Malaysia. For the second component is push button. We are using two push button that cost 5 ringgit Malaysia. The third one is variable resistor, and it is cost only 1 ringgit. For the next component are the resistor, and it costs only 1 ringgit. For the fifth component is buzzer. Buzzer that will operate when the level of glucose exceed 150. and it is cost only 1 ringgit 50 cent. For the display, we are using LCD, and it is cost only 30 ringgit Malaysia. To pump the insulin uh, to operate the insulin pump, we are using DC motor that are cost for 12 ringgit Malaysia. And to make the DC motor running, we need we are using 12-volt batteries that connect to the device, and it is cost only 3 ringgit because we are using only one uh, component for the one quantity for the battery. And the driver motor is the device that we use to control the DC motor, and it is cost only 7 ringgit. The last component for this project are the glucose sensor. Glucose sensor are the most expensive component for this project because it detect the glucose from our body, and it costs 282 ringgit Malaysia. For all the listed component in this project, the total for this project is 405 ringgit. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amirul Amin bin Kamian. My metric number is AN190087. So now I will explain about the project 3D prototype. I sketched this prototype using a SketchUp software. So we can see that the device contain a LCD display glucose level, and they have two buttons on the devices. The upside button is the on off button, and the downside button is the reset button. The device have a buzzer in this place. So this is the glucose sensor, and this is a wire which connecting to the glucose sensor to the devices. So inside the device, it contains a DC motor. When glucose level reach 50, DC motor is start to on. After that, when glucose level reach 150, buzzer is started to on and beeping for 30 seconds to notify a user about glucose level has reached 150. After 30 seconds, the buzzer is turned off, and after the glucose level below 150, buzzer is turned off, and when the glucose level increase to 150 again, the buzzer will turn on again for 30 seconds. So that's all from the explanation about the project 3D prototype. Thank you. Assalamualaikum warahmatullahi wabarakatuh.